Solving equations using additive inverse. Let's go over a couple of ideas. Additive inverse of a quantity has opposite sign. Solution to an equation has a positive variable all by itself on one side of an equal sign. An addition principle of equality is that if you have true statement like we have here 5 equals to 5, and let's say we add same number to both sides, and in this example we're going to add 20. On each side we're going to get same number. We still have equality. You can also add a negative number to both sides of an equal sign, and we will have 18 equals to 18. Now let's say we have 12 equals to 12. If I only add a number to one side of the equal sign, there will be no equality. Applying additive inverse in solving process. The goal is to have a positive variable all by itself on one side of the equal sign. You want to simplify each side of the equal sign whenever possible. You can add additive inverse to both sides of an equal sign to undo addition or subtraction in the process of getting to the solution. And let's do some examples. So here we have x plus 12 equals to 26. We have three terms here, and we can choose three different additive inverses. However, the only useful one would be additive inverse of positive 12, because it will add up to 0. So if I have positive 12 and we add negative 12, this means we will be adding a 0 to x. So these two terms will add up to 0, and you would still have x there. But whatever we do to one side of the equal sign, you want to do the same to the other side, and we get 26 minus 12, 14. So x is equal to 14, and this is our solution. Over here we have 27 equals to x minus 5. Goal of the game is to solve for the variable. So I want that variable all by itself. We have negative 5 on the same side of the equal sign with the variable. So the useful additive inverse, find additive inverse of negative 5, and in this case it would be positive 5. Whatever you add to one side of the equal sign, you want to add to the other side of the equal sign. So negative 5 plus 5 will add up to 0, and x is equal to 27 plus 5, 32. Since you have positive variable all by itself, this is your solution. Even though usually you see this answer written as x equals to 32. It's the same thing. In example number 3, we actually have like terms on one of the sides of the equal sign. You want to simplify before you solve. That's a rule of thumb, always. So we have different signs. We're going to look for difference between 15 and 3. Difference is 12. We had more negatives, so it will be negative equals to x minus 4. Now we apply additive inverse, and negative 4 will add up to 0 with positive 4. Whatever I add to one side, I want to add to the other side of the equal sign. Negative 4 plus 4 is 0. On the other side we have different signs, so we calculate difference between 12 and 4, which will be 8. And we had more negatives, so we have negative 8 equals to x. X is positive all by itself, so this is our solution. And a lot of times you will see this, x equals to negative 8, which is exactly the same thing. In example number 4, once again we have like terms that we can combine before solving. So on this side we have x plus 7, these terms are not alike. On the other side we have different signs, so we calculate difference between 22 and 5, which is 17. And we have more negatives, so the difference is negative. Once each of the sides is in the simplest form, we proceed to solve. Now, there is a 7 that is being added to x, and the opposite of adding 7 is taking away 7. And whatever you do to one side of the equal sign, you want to subtract the same thing from the other side. 7 minus 7 is 0. So we have x equals to, same sign, we calculate sum. It will be negative 24. And this is our solution. In the fifth example, we have x plus a quarter. And we want to undo adding this 1/4. So the opposite would be to take away 1/4. Whatever you do to one side, you want to take away from the other side, the same thing. And positive quarter will add up to 0 with a negative quarter. And we have x equals to, adding fractions. We keep the denominator, copy the numerators. And this whole thing will become 3 minus 1, 2 out of 4. We can reduce this fraction by 2. So x is equal to 1/2. And this is our solution. Over here we have two fractions that we can combine. Before we get to combine them, we need to bring them under a common denominator, which would be 15. So we need to multiply 5 by 3. Whatever you do to denominator, you want to do the same thing to numerator. So now we have out of 15, 4 minus 3 times 3, 9, equals to x minus 2 out of 3. So now we have out of 15 different signs. Difference will be negative 5 equals to x minus 2 out of 3. We can reduce this fraction by 5. So we will have negative 1 out of 3 equals to x minus 2 out of 3. Now we can solve for x by adding 2/3 to both sides of the equal sign. This will add up to 0. And on the other side we will have out of 3, negative 1 plus 2 equals to x. And the difference between 1 and 2 will be positive 1 out of 3 equals to x. And this is our answer. Or you can say x equals to 1/3. That's all.